Here's another volume and area question. This is number 5 on the 2022 instance of the exam. Okay, so it gives us figure 1 and 2 here. Okay, so figure 1, let R be the region bounded by the graph of y equals 1 over x. The x-axis and the vertical lines x is 1, x is 5. Figure 2, let W be the unbounded region between the graphs of y equals 1 over x squared. The x-axis that lies to the right of the vertical line x is equal to 3. Find the area of region R. Okay, so this is just area under the curve, which is integral. So it's the integral from 1 to 5, 1 over x dx. Okay, what's the antiderivative of 1 over x? That's just natural log absolute value x. Do fundamental theorem in calculus, so evaluate from 1 to 5. This is just ln 5 minus ln 1. Ln 1 is just 0, so ln 5 is the answer. Okay, 1 point for the definite integral. And then 1 point for the answer. 1 point here, 1 point there. Okay, part B. Region R is the base of a solid. For the solid, at each x, the cross-section perpendicular to the x-axis is a rectangle with area given by x e to the x over 5. Find the volume of that solid, of the solid. Okay, so we just need to find the area of each cross-section. By the way, cross-section perpendicular to the x-axis, that means dx probably. Okay, and the area of each cross-section is right here. Okay, so it's the integral from 1 to 5 of area of each cross-section times dx, the very infinitesimal width. Okay, this is integration by parts. You're allowed to do the tabular method according to the scoring guidelines, so that's what I did here. I chose my u to be x, differentiate it until we get to 0. Whatever's left is e to the x over 5. Technically, there's a dx there. Okay, integrate it just as many times. Okay, start with plus, alternate sign, and then you go across, diagonal down. Cross, diagonal down. So it'll be 5x e to the x over 5 minus 25 e to the x over 5. Evaluate from 1 to 5. To fundamental theorem calculus, plug in the upper bound, minus plug in the lower bound, simplify. Honestly, this should be fine, but if you simplify, it's 20 e to the 1/5 power. 1 point for the definite integral. 1 point for doing this stuff here. Tabular method. Okay. And then 1 point for getting to here. If we do the tabular method, looks like, okay? And then 1 point for this final answer, okay? Part C, find the volume of the solid generated when the unbounded region W is revolved about the x-axis, okay? So this is going to be the disk method, okay? So it's pi integral r squared dx, where r is the length, this length right there that I'm kind of drawing with my pen. That's the length, that's 1 over x squared, okay? So pi integral from 3 all the way to infinity, r squared, as I was saying, is the function squared dx. We gotta write the limit notation because this is an improper integral. That's probably critical in the scoring guidelines. I haven't looked at this one yet, okay? So that's this right here, okay? We integrate as normal now. This is just power rule. So that's here, fundamental theorem calculus. Evaluate the limit. This goes to 0. You still have this minus 1 over 27. 2 negatives make a positive. So honestly, I would just keep it this, but we can simplify to pi over 81 if we're good enough to do that. Okay, so scoring guidelines. Improper integral is the first thing. You need this, looks like. Okay. And then antiderivative, this part is 1 point. And then evaluating to here, that's the last point. Okay. All right, that's it for this problem. Not too bad. Lots of just setup, looks like. But the evaluations were not bad at all. Okay. Please give this video a like if it has helped you in any way, and hopefully I'll see you in another video as well. Bye.